everyone. Today, we from Group 4 from HB2 will cover on the topic of machine learning. So, the agenda that we will walk through today is the introduction, the history of machine learning, advantages and disadvantages, and also not to forget that we will cover on the application of machine learning and also the types of machine learning. So, for the introduction, what is machine learning? Machine learning is a discipline of artificial intelligence that provides machine with the ability to automatically learn from data and past experiences while identifying patterns to make prediction with minimal human intervention. So let's take a look briefly in the history of machine learning. So in the 1950s, Alan Turing suggested that machines should think like human. Hence, the first neural network then was built by Marvin. In the 1960s, Arthur Samuel coined the term of machine learning. In the 1980s, Geoffrey Hinton helped by making the backpropagation algorithm. So in the 1990s, SVM, or also support vector machines, became a popular tool for classifying data. And then in the 2000s, finally, data mining became very important for many applications. Thus, the interest in AI grew again thanks to deep learning of the machine learning. Not forget the advantages and disadvantages of machine learning, because everything in this world has its own pros and cons. So for the advantages, it is improved accuracy and precision in many works, automation of repetitive tasks, enhanced human capabilities, enhanced decision making, and also personalization and customer experience. For the disadvantages, there are ethical concerns, security vulnerabilities, legal and regulatory challenges, and also maintenance and updates, not to forget data dependency.
For my part, I'll be presenting an overview of key types of machine learning, which is basically there were three, which is supervised learning, unsupervised learning, and also semi-supervised learning. Let's start with supervised learning. So in supervised learning, the model is trained on a data set that include input-output pairs, where each input comes with a corresponding level. The goal is for the model to learn a function that maps inputs to the correct outputs. Let's move to semi-supervised learning. So basically, semi-supervised learning is a hybrid approach that uses a small amount of labeled data with a large amount of unlabeled data. So it is particularly useful when labeling data is expensive or even time-consuming. Let's discuss about unsupervised learning. So in unsupervised learning, the model is given data without any labels. So the goal is to uncover hidden patterns or groupings in the data, and a common task in unsupervised learning is clustering, where we aim to group a similar data points together. Okay, moving up, I'll continue my presentation by showing example for each types of learning. Okay, first of all, the example for supervised learning, which is basically linear regression, which is used to model the relationship between a dependent variable and one or more independent variables. Next up is example for semi-supervised learning, which is basically label propagation algorithm, which is basically a graph-based algorithm that works by propagating labels through a network of data points. And finally, the example for unsupervised machine learning, which is k-means clustering. So basically, k-means clustering aims to partition data into distinct clusters. The number of clusters is chosen in advance. So basically, k-means is widely used in tasks like customer segmentation or image compression, where grouping similar items is essential.
Now, let's move on to the next part of this presentation, which is the applications of machine learning. Applications of machine learning are self-driving cars. Today, there are several cars with semi-autonomous driving features, such as Tesla's Model S and BMW's X5. Manufacturers are working hard to make fully autonomous cars a reality for consumers over the next decade. Next, machine learning can also be used in fraud detection. Machine learning can help financial institutions detect fraudulent transactions and save consumers from false charges by flagging those that seem suspicious or out of the ordinary. Mastercard, for example, uses machine learning to flag scams in real time and even predict some before they happen to protect customers in certain situations. Lastly, in the stock market, there is always a risk of ups and downs in charts. So for this, machine learning's long and short-term memory neural network is used for the prediction of stock market trends. This would allow for the better foresee of stock markets whether in local countries or internationally. In conclusion, machine learning has revolutionized various fields by providing innovative solutions and enhancing decision-making processes. As we continue to advance in technology, the potential for machine learning to transform even more sectors is immense. Embracing this innovation will also create new opportunities for growth and development. Thank you for watching.